So here we're going to go over atomic basics as well as some explanation of the periodic table. Now specifically, we want to think of atoms like building blocks of matter, like these Legos kind of were put together to form the Statue of Liberty. Here we're seeing them being assembled, and we can think of bonding atoms together that will create molecules, which will then produce larger forms of matter. Again, like Legos connecting. Now that matter, how we define it, is physical properties. So these are observations that do not alter the composition of the matter. So we see with the dog smelling, looking, potentially tasting. Now these physical properties of matter, matter has mass, and mass is a property that measures its resistance to acceleration, or general measure of the number of atoms present. Trains have talked about a lot of mass. This hot air balloon represents volume. It's the amount of space an object takes up, and volume is measured in cubic units. We also have density, which is a measure of mass per volume, and these ice cubes float in this iced tea because they are less dense than the liquid. Now in atoms is a good representation at vibrating in place. We have electrons, protons, and neutrons. Keep in mind their location, charge, and mass. This atom here has one proton, so this is hydrogen, which has two neutrons and one electron. Now we can even take an atom and break it apart to even smaller components, but we really want to focus on the electrons, the protons, and the neutrons, knowing their mass and knowing their relative charge as well. This will help us develop a better understanding. We don't have to get all the way down to the quark. Now looking at this nucleus, this representation, this is containing protons and neutrons, and this is represented by the woman here. The dog kind of represents the electron. As we see here, with a kind of a proton neutron being located in the nucleus, bonded together, the electron not too far by, but is able to move a little bit around that central nucleus where the protons and neutrons are located. Now we're going to get into periodic table basics. So we kind of look at now the atoms. Now we're going to see how this periodic table is organized. And initially the periodic table might seem overwhelming, but once you understand the organization, it becomes easier to understand. It looks like a lot of letters and numbers, and it is, but there's a method to the madness. You can think of it as like a calendar. Now a calendar is great because it provides an easy to follow pattern. Once you understand that pattern, it really allows you to make a good kind of understanding of atoms you might not be 100% familiar with. This is the standard periodic table, basic organization and layout located here. Notice the key, and it tells you the oxidation numbers, the atomic mass, the name, the symbol, and the atomic number. You want to focus on typically the first 30 elements or so. Those are going to be kind of your most common that you may work with or encounter with. But if you're noticing this, there's different colorations. That's for classifications in metal, metalloids, and nonmetals. But these vertical columns are very important because these vertical columns represent families. These families have similar properties. So if you're not familiar with what an atom is, if you know what one is in the family, you can make inferences about the other. I mentioned those general categories. We see that nonmetals are located mainly on the right-hand side in the yellow coloration. Don't forget about hydrogen, that's also a nonmetal. We have the stair step, which is the metalloids, with everything else being classified as a metal. Now those families I mentioned, you can see alkaline metal family, alkaline earth metal, that's family number 2. A lot of students mix those up. Transition metals, boron, carbon, nitrogen. We have the halogens and noble gases all the way on the right-hand side. So it's important to be aware of those families. Now here's a periodic table, again listed out just like we saw earlier, little different colorations because you don't want to get locked into just looking at one particular periodic table. They all basically tell you the same information. It's being able to react to what different organizations, different colors, those may look like. Again, the organization is going to be relatively the same, and the coloration may change, but they're telling you the same information. Now, what gives these atoms their properties? Electrons and neutrons can change. Now, this gives the atom or bond's energy. Energy is the capacity to cause change. We see here the swinging pendulum that is representing energy. We also have the types of energy. We have potential energy, which is stored energy that can be released and is stored in the bond's molecule. In contrast to that, we have kinetic energy, energy that is currently used in a reaction. We see the cat walking away. Now we have electron energy levels, and these are electrons that state the potential energy. You can think of them like rungs of a ladder. In addition, we also have something called valence electrons, and these are electrons with the highest principal energy, and they determine the chemical reactivity. Elements in the same group or family seem the same valence electron number. We see the fish swimming here. You can think of the valence electrons on the most outermost side. That's what's going to come in contact with different bonds. Now, we like to think that electrons work in those nice little circles. Technically, electron orientation, you want to think of it as birds around a feeding point, in the sense they're most likely to be in that center portion, but they can be found throughout and around that entire area there.